Hello everyone, I'm Monisha. I'm going to explain our project on behalf of our team members. Our project title is IoT based small crop protection system for agriculture. Let's move on to the introduction. As we know that the crops in the fields are sometimes devastated by the animals, which leads to the low productivity as well as the huge financial loss to the farmers. There is also the need for the farmers to visit the fields at night time to control the motors and the pumps in the field. Thus, we need an intelligent system to overcome these difficulties. Then, these are some of the existing solutions for our project. Moving to the next page. The main objective of our project is to increase productivity and to protect the crops from the animals and the birds, and to make easy control and remote monitoring of the motors, and to avoid the farmer to visit the farm in night time. This is the block diagram of our project. The main aim of our project is to detect the animals. Once animal is detected, it sends it to the clarifier service, which can detect whether it is an animal or not. And the image is as well as stored in the object storage and the URL in the cloud and TV. The IBM Watson IoT platform, which is act as a mediator to connect the IoT device to the web application. The web application is developed to visualize the soil temperature and the soil moisture, humidity levels. Next, moving to the next page. These are some of the methodologies and the services that we have used in our project. Python script. The Python script is used to connect the cloud object storage, cloud and database, and the IBM Watson IoT platform and the clarifier services. Let me show the code. This is our Python code in which we have imported many libraries in order to run the program. The CV2 library is used to process the video, and in order to connect to the IBM IoT platform, we have used this. The IBM Boto3 library is to upload the image to the cloud object storage. The cloud and libraries are used in order to connect to the cloud and DB and upload an image URL to the cloud. These are used in order to connect to the Clarifier service. As I said earlier, Clarifier is an online website. As we send some image to the Clarifier, it decides whether it is an animal or not. In order to connect to the Clarifier service, we are using its credentials. And in order to connect to the cloud object and the cloud and DB services, we are those credentials also. The create resource, it is used in order to connect to the particular cloud object storage and the cloud and database services. The multi-part upload function is used to upload the image to the cloud object storage. To upload the image to the cloud object storage, we need its bucket name and the item name and the file path where the image is stored. Then in my command callback function, when we click the web UI and backend message in the JSON format is sending back. Depending upon the command that is received, we print the commands here. Then in order to connect the IBM IoT platform, we are using its credentials, that is organization ID, type ID, and the device ID. Here we have created the sample database. And just for our acknowledgement, we have, if the database is created, we print the successfully created. And the main motto of our project is to detect the animals. Here we have a process, we are going to process the local file named as garden. What happens is the file opens and it processes the video frame by frame and sends it to the clarifier service. For that, we have used the clarifier service model ID. If there is no response from the clarifier service, then it will print detect is equal to false. If any message is received from the response, that means label is received from the clarifier service, first it check for the concept value. For the data which has the concept value greater than 0.98, it check for the concept name. If the concept name equal to animal, then it will print the alert message, alert animal detected, and it will also play the sound alert.mp3. This audio is created using the text to speech service. I will show it later. And If the animal is detected, it print that detect is equal to true. Then here we have generated the random values for moisture and the humidity, and the data is uploaded to the cloud in the form of JSON format. Here the command callback function is used to detect if any command is received or not. If any command is received, it will invoke the command callback function here. It will invoke the command callback function. Then if any key is pressed, or if any Q or key is pressed, the client will disconnect and the video will disconnect. That's all about the Python code. I will show you the text to speech program. Here we use the alert warning as alert animal detected. You can use any other warning messages. That's all about our Python code. Let's move to the Node-RED. This is the node flow diagram used for our project. In order to get the data from the IBM IoT platform, we are just including its device type and the device ID here. Then once we have got the data from the IBM IoT platform, we are splitting up into the moisture data and the humidity data. In the HTTP request, what we are trying to do is we are trying to get the data from the cloud and database service. For that, we are giving its a URL and the username and the password of the particular cloud and database service. From that data, we are going to extract the link only, that is the image link here. Then moving to the template node, that is, or the dashboard node. In this we are uploading only the image URL. That means once we click the button, we are going to get the image in the web UI page. Then here we have kept some buttons in order to give the commands like light on, light off, motor on and motor off. Then in the IBM IoT platform, as we are sending the data, we have set the output type as device command and the device type and the device ID here. So that's all about the node flow of our project. Let us deploy this. So it shows that successfully deployed it. Then let us see the web UI page. This is how the web UI page looks like. Let us see the frame, and it will send to the clarifier service where the clarifier is going to give some response. If the response is equal to the animal, then some alert message will be play. Otherwise, it will print a detect is equal to false, and and it will also print some random moisture and the humidity values. So let's see the output. To run the program, just click on the run. So it is going to open the file. So it is going to open the file. So it shows the successfully created. So here see, it shows the connected successfully. And animal, as we are given the garden video, it shows that animal is equal to false, and the moisture as random values, moisture and humidities are showing the random values. Now let's say the web UI. So here the moisture and the humidity values are changing randomly. So let's see the command that we are giving in the web UI as it shows in the Python. So I'm giving the command like light on and motor on. So let us see. So see here, it prints the commands light on and the motor on. Okay. So let's see here, it shows the command light on and the motor on. Okay. So So I'm going to see the image. Click on the button to get the image. So this is our image. As we give the garden, this is the frame which is used in this video. Okay. So let us change our input video to the monkey.mp4. Let us save this and we are going to run this program for the output.
Alert, alert, animal detected.
As the animal is detected true here, it is playing the alert animal detected message. As we have given the previous input in the web UI as Motran, it is printing here. So this is our output of our project. So let us check the image of the animal in the web UI service. For that, just click on the button. So this is the image of the animal. Then these are some of the reference links we have referenced for our project purpose. Thank you everyone.